Good evening, students. I'll start with the class. In the previous class, we were solving problems based on how to calculate the tension. Okay, so we know that anytime any object of any mass is hanging on a surface or clinched to any fixed surface, if this is the mass of the object, there is always a gravity which is pulling it down. But this object doesn't fall because there is an equal and force which is pulling it upwards, and that upward force is called as tension. Okay, so for a hanging object, or meaning without contact to any surface, this is the thing. So if it has many strings, those many tensions will be there. So this would be T1, this would be tension 2, and this would be a normal gravity. Remember, the arrows are always going away from the object. Tension arrows will be always opposite direction from this. It will never come towards the object. This is when it is hanging or in the air. Suppose if it's on a surface, we had seen the table example, then there is a force. This is always common irrespective on which is the situation. So this is a table, or this is called as a surface. It is lying on a surface. Now there is nothing to pull it up. It is not hanging on something for it to be called as tension. In this case, whenever any object is kept on a surface, you know that still the object doesn't fall down because there is an upward force which is acting on it, that is called as a normal force. So in case of hanging object, it is called tension, and in case if it is kept on the surface, it is called normal force. Again, this is in the opposite direction, and always this T will be equals to this mg, and this N will be equals to mg, as long as they are exactly in the opposite direction. Both should be 90 degree to the surface. Normal and mg should be perpendicular to the surface. Even here also, this tension, the string should be making a perpendicular angle with the surface. Now, suppose if this line is not making a perpendicular, then what to do? We'll see the next problem. This is 37 degree. This is 5 kg. This is tied over here. So let us calculate all the tensions. Now, obviously, here it will be tensions because that object is not kept on a surface. Only when it is kept on a surface, the normal will come into picture. Now, we'll try to draw normal. This is suppose the question. Now, we'll try to simplify with many diagrams as it is. So we won't draw this, not required. So right now, one is like this, one is like this. Now, which anyone can name. Okay, this you can name as T1 because this is getting pulled this side, and this side is T2. So one tension I can name as T1, the other one I'll name it as T2. Something is still missing. Which other force is there which I missed? Is the diagram complete? All the arrows? What is missing? First. Now this is in space. Is the only thing why these tensions are coming into picture. So only if tensions are there, this will go up or fly up in the sky. Why is it balanced? Why is it at rest? Which are the forces acting?
T.
Which one?
Gravitational force.
Yes, this is missing. Every time for every object, you cannot miss out this. Even given or not given in the this problem, you have to write this. Gravitational force, that is the weight. Okay, will always be acting on it. So this is a complete diagram. Means of you have found out your tension, you have named the tensions and the gravity. Now, this tension is not exactly perpendicular now. If it was exactly on the opposite side, it would have balanced each other that way. But now, whenever you don't have a perpendicular line, whenever any vector is there, it will always have components. You have to split it into two components. So what is going to happen? It will have one horizontal component and one vertical component. Whenever you have horizontal, we know that this will be T2 cos theta or sin theta, we will see. Now cos theta is always which side, whichever is attached to one particular angle. Now we'll see which angle to take, whether this angle or this angle. If this angle we are taking, then cos theta will come this side, sin theta will always be on the opposite side. But if we are taking this angle, then cos theta will come here, sin. So we'll see this diagram now. So as per that, you see, this is 37 degree. These are alternate angles. So this will also be 37 degree. This angle is always equals to this. Any two lines are parallel and you draw a line like this, they are called as alternate angles. They will always be equal. So as per that logic, the angle between this line and the box is 37 degree. So we know that the angle is 37 degree here. So this theta we will take now. So as per that logic, this will be T2 cos theta and this will be T2 sin theta. Now we'll calculate those components. So we have resolved this vector into two parts, the component parts. So we'll calculate what is T2 cos theta. T2 cos theta is nothing but T2 into cos of 37 degree. Theta is 37 degree. Now I told you whenever the angle is 37 degree, there is direct shortcut. You have to remember this triangle for 37 degree. Hypotenuse is always 5. For 37, opposite side is 3 and this is 4. So cos theta is this adjacent upon hypotenuse. So cos theta is always 4 by 5, sin theta is always 3 by 5. 37, sin 37. If you directly remember the values, no need to draw the triangle. You can directly substitute cos 37 as 4 by 5. It will never change. Cos 37 will always remain as 4 by 5. So this component is 4 by 5 times T2. Same way calculate this one. The vertical component is T2 sin theta. That is T2 sin 37. So T2 into 3 by 5. 3 by 5. You can write like this also. This fellow is 3 by 5. So we got the components. Now we'll draw the final diagram, simplified one, without any this. angles. So finally, this vertical means what? This is a component acting this side on the object. So whether I put it at a corner or at the center, it doesn't matter. So as per the logic, this is anyways T1, this is mg. Now this is vertical acting on this. So instead of drawing it at the corner, what I'll do is put it here. But direction should remain same. So it is acting upward. So this will be how much? 4/5 T2. And this is how much on the horizontal side? 3/5 T2. 5K. Has anyone not understood this? You can ask. No. Always remember the opposite ones are always equal. You know that equal and opposite should be the opposite directions. It should be. So vertical will be equal to vertical. Horizontal one will be equal to horizontal one. So we can equate this. So 4/5 T2 will be equals to mg, because these two are balancing each other and horizontal are balancing each other. Now mass is how much? 5. Consider G as 10. Means take 5 that side upon 4. Okay, so that will be 62.5 Newton. Now we'll calculate this component. This will equate. So we got the value of T2. Now we'll calculate T1. So this will be equal to this. So substitute, you know what is the value of this? You can put this also for calculation point of T2. You can take as 125/2. I2s are 10, 5/5s are 25. This will give you 75/2. So 37.5 you will get. So we got the tension T2 and T1. Any doubt in this problem, you can ask. Next question. This is 60°. This is 30°. They are just finally attached to this string. This is making 30°. Calculate the tension. No, obviously both are inclined, they are not perpendicular. One is like this, 30 degree, one is 60 degree. This you can name it as whichever one, T1. This you can name it as T2. There will be MG. This one is root 2 kg. No, we'll have to find components. Even this one will have horizontal as well as vertical component. This one also will have horizontal as well as vertical component. I'm not drawing it at the same point because it will look like a mess. So every time I just go on so that when you're studying back, you know what has been done. So for this one, what I'll do, this is 30 degree. So this will have a horizontal component as well as a vertical component. Now this 60 degree also. Okay, first we'll mark 30 is this. This is T2. Now which is the angle we are considering? This one. So this will be T2 cos 30. Whichever line is attached to the angle will have cos. Okay, the horizontal component. Now this will be T2 sin 30. This is with reference to this angle. Now this is another 60 degree. So this one will also have horizontal. Now what is happening? The vertical components are clashing with each other. So I'll just draw one more just for you to understand. They are both clashing. Now this will be the one attached to the angle component will be T2 cos 60 and vertical will be T2 T1, sorry, this T1. T1 cos 60, this will be T1 sin 60. Horizontal this for this and the vertical component. So now we'll remove this. The moment we write the components now, this fellow has no use, the inclined one, because we already resolved a vector into two parts. Now after resolving whatever diagram we have, last final calculation one, we'll write it. So what is T1 cos 60? Cos 60 is always 1 by 2. This will be how much? Root 3 by 2. Top, there are two of them. T1 into sin 60 means how much? Root 3 by 2. T1 and half T2. Sin 30 means half. Sin 60 means root 3 by 2. This is a simplified diagram after finding the component. This is root 2 kg. Now, first, there's no point equating these two equations because we don't know T1 also, we don't know T2 also. But we know some relation will be there. You can just equate like this and keep, it will be useful in this. So what we'll do, we know that this horizontals are always equal. As per that logic, root 3 by 2, T2 will be equals to half T1. This is the first equation we will get. So 2 and 2 will cancel. Anyways, if you take 2 on this side, it will cancel. So we know that T1 is root 3 times T2. So put this as equation 1. No. Second, equate these two. Now what is happening? There are two here, two of them, and they are both going in the same direction. If both are going in the same direction, it is always they get added. Okay, one is going in this side, one is going opposite side, then they will get minus. So these two are getting added. So as for that, what equation we will get? Root 3 by 2 T1 plus half T2 is equals to m. Because there are two forces which are acting upwards. So this plus this will be equals to m. Now we don't know T1 also, we don't know T2 also. This side we can substitute. This is how much? Root 2. This you can take as 10. Now, this both we don't know, but we know this relation. T1 is how much? Root 3 times T2. So wherever there is T1, we can put it as what? Root 3 times T2. From where did I get? From equation 1. So put the value of T1 as root 3 times T2 from equation 1. Now we can calculate. This is half T2 root 2 into 10. Right. Mass is given to you. That is root 2. Now root 3 into root 3 is 3. And root 2 can write. Denominator is same. Three plus one give 4 T2. This 2 will go up. This 4 will come down. 5. So T2 is how much? 5 root 2 Newton. Now use the equation 1. Calculate T1. What is equation number 1? T1 is nothing but root 3 times T2. Whichever way you write, no problem. T1 can be written this side or this side. Now put the value of T2. This is root 3. So root and root always gets multiplied to each other. So 5. So we got both the values, T1 and T2. Next one. Only this much has been given. Calculate the tension. or whatever the forces whichever have been applied on that. Now remember, this fellow is kept on a surface. So definitely there will be a normal force which will be coming into picture now. Whenever any object is kept on a surface, there will be always a normal force which will be acting upward, which is always the normal force is perpendicular to the surface. Okay. It should be perpendicular to the surface. Now, obviously, wherever it may be kept, there is always a mg will be acting vertically downward straight. It will not change its angle right now, because that will be anyways irrespective whether you are keeping the slanting, and gravity will not take an angle and come this side. Okay, so anyways mg will be straight downwards. Like, since it is attached to one string, there will be a tension here. This is a normal. So what all we have to calculate now? Normal also as well as the tension also. This is theta. Now if you notice, this mg had to be exactly in the opposite direction of the normal, then only you could balance out. Now we cannot say n equals to mg. It will be wrong. When n was mg exactly in the same direction, but same angle, opposite direction, they should be in the straight line. But now what is happening? This fellow is crooked. See, mg should be making what? 90 degree with the angle. With this surface, it should have been making 90 degree. But is this angle 90 degree? No. Okay, so what will happen? This fellow will have components. This should be exactly like this, the opposite side of this. So if you try to draw this now again, this is the normal, this is your mg. Now same how we had for this, mg will have two components. One will be this horizontal, whatever side, and one will be this. So these will be the two components of mg. And now it is 90 degrees. And now this component will be exactly opposite to this. But now what we have to do, we have to calculate what is the angle theta. Either this angle or this angle we have to know. Because if we are taking this as theta, then this will be cos theta, this will be sin theta. If we are taking this as theta, then this will have to take sin, and this one you have to take cos. Adjacent side, whichever is attached will be always cos. So now we'll have to see which angle is this, or which angle is this one. So I'll draw this again, the same triangle. If you notice, I'm drawing this triangle down. You see. This is 90 degree. This is the same triangle I'm drawing now. I'm not doing it here because it will look mess. This triangle I've just shifted here. If this is 90, this is theta, what will be this angle? Tell me. How much will be this? Yes. Yes. So this will be 90 minus theta. If this is 90 minus theta, what will be this angle? Again, this is perpendicular. Whole thing is 90 degree. So how much will be this one? If this is 90 minus theta. Isn't it 90 minus 90 minus theta? This, see, consider if this was 30 degree, what this would become? 60 degree. And how much would this become? if this was 30, this would become 60. Then how much would this become? Total should be 90. How much would it be?
30.
30, which is same as this angle. So as per that logic, this will be theta. Even if you calculate, full thing should be 90. So 90 minus this angle. 90 minus 90, we will get back this as theta. So this is your theta. So if this is your theta, what will be the components? This will be mg cos theta, and this will be mg sin theta, and this is your n, and this is your tension. So these are exactly opposite, and these are exactly opposite. So as per that logic, now values are not given, only in terms of formula you have to write it. Now n is exactly opposite to this, so n will be equals to mg cos theta, and who is opposite to this? T. T is opposite to m sin. So if values were given, then you have to just substitute. If you know what was the angle, if this was 30, this would have been 30 and 30. If mass was given, you have to just substitute them. Mass, how much? 5, then 5, and gravity you would know. This is how we can calculate normal and tension. If not given any value, in general we have to find like this. If you want still a simplified diagram, it will look like this. This is n, this is mg, exactly in the opposite direction. Mg cos theta, this is what? Mg sin theta, and this is your tension. So this is equals to this, and this is equals to this. Now next, we need to know what is called as momentum, because we are moving on to the Newton's second law. For that, we need to know what is momentum. Momentum is nothing but it's a product of mass and velocity of any object. Defined as velocity of the body. Also called as a linear momentum. You can write it as linear and keep. Now we cannot use, since the word momentum is there, we cannot use mass, m, for momentum. Why? Because already in physics, m we denote for mass. So we cannot use this m and get confused. So the letter for momentum is E. As per that logic, momentum is nothing but product of mass into velocity. So this is definitely momentum is dependent on the velocity. So it's a vector quantity. So it has both magnitude as well as direction. Unit for momentum, mass is given in terms of kg, velocity is given in meter per second. So unit is kg meter per second. Okay. Now we'll see what happens if the body is at rest. If the body is at rest, there is definitely no movement. Okay. So what will happen? Mass will obviously be there, whether this is 10 kgs or 20 kgs or 100 kgs, doesn't matter. So what do you think? What will be the momentum at rest? Think of the product. What is the formula? M into V. Mass will always be there. At rest, what is the velocity? What is always the velocity of speed of an object at rest? If the
0.
object is not moving, the speed will be 0. So remember, momentum of any object at rest is 0. Now if the object starts moving, okay, initial. Or you can say initial momentum. The moment it starts moving, you can consider into velocity. So this will be what now? Initial velocity. So what letter will come up? U, because we usually write U for initial velocity. And denoted as Pi. Final momentum, if it was moving and then at some point it will come in. So this is just starting and this is already moving. It's velocity V, suppose. So P will be M into final velocity. That will be V. And this letter is used as PF. Final velocity momentum is given to as MV. So initial momentum is mu, final momentum is mv. Now when does any object at rest start moving? Definitely when a force is applied. Otherwise, as per the first law of Newton, what we know that this object will remain at rest forever until and unless some unbalanced force acts on it. So until and unless some force starts acting on the object, there will never be any momentum. So when momentum will come into picture? Only when there is some force and then it starts moving, then only there will be some momentum. Otherwise, it is always 0. So Newton's second law of motion, it states that the rate of change of momentum is directly proportional to the force and takes place in the direction of the force. it states that the rate of change of momentum is directly proportional to the force and takes place in the direction of the force. What does this mean? Directly proportional means the word as force increases, if you apply more force to any object, what will happen? Its velocity will increase. If its velocity increases, what will happen? Momentum will increase. Why? Into v. If this number is increasing, definitely p is also increasing, because your if multiply by 5 means this will be 5 times m. Velocity is increasing to 10, definitely this is also increasing. So force, whatever momentum is directly proportional to force. So momentum will increase. If velocity increases, then just that momentum will also increase. Takes place in the direction of the force, definitely whichever way you are applying the force, that direction you will have momentum. Now what does this word rate of change of momentum mean? Rate of change of momentum formula is always change in the momentum per unit time. So this is given to you as dp upon dt. Change in momentum per unit time, and which is nothing but your final momentum minus initial momentum. Same like velocity. How we had change in velocity is nothing but final velocity minus initial velocity upon time. So change in momentum will be nothing but final momentum minus initial velocity momentum upon time. So based on this, we'll derive an equation for force. So what all we know? P is mv. We know that rate of change in momentum is final minus initial. So this is a derivation to find the equation of force, formula for force. Now under this we'll see some word called as constant force. Now there's an object which was at rest, suppose. Okay, then what will happen? It's moving. Then with initial moving it will start. Okay, so initial will be u. Then suppose if I'm applying a constant force means because it has to keep moving, okay, at some point. If I'm applying a constant force, then this will have some velocity. Definitely this was having some initial velocity. Suppose he was moving at 10 meter per second. Now I applied some force which will move at 20 meter per second. Now this 20 meter per second will never change until and unless I'm changing this force. Okay, but I'm applying a force such that it always remains same. Only when I change the force, it will either increase or decrease its speed. But if I'm applying constant means what? Same force. Same force I'm applying throughout the motion. That means this fellow will never change. Okay, so this will always continue to remain as 20 meters per second until and unless I'm changing the force. So the equation we have to start it as, let us consider it was initially moving at 10 meter per second. Then we apply some force and it will change to some other velocity. So let us consider a body of mass m. This is only for example, you don't have to draw this diagram. Moving with initial velocity u. So we are assuming that starting at the start, this fellow is moving. That object is moving at some initial velocity u. So what will be the initial momentum? Therefore, initial momentum will be, I just gave you some time back how to calculate the initial momentum. Is nothing but Ei, which is nothing but m into u, because initial velocity means uv. So this will have pi, which is m into u. This will have pf, which is m into v. Final means v. Then what happened? This fellow was moving. Then what we are doing? We are applying some force. So let F be the force. Okay, let F be the constant force acting on the body for t seconds. We cannot do it for forever. Maybe for some time we are trying to keep the constant force, okay, as 20 meters per second. So we don't know how much is the time. Let it be t. So what will happen? Now the moment you are applying a force, this velocity will change. If it was moving at 10 meters, I told you it will maybe start to move at 20 or whichever, based on how much force you are applying. So now what will happen? As a result, its velocity will change from u to v. As a result, its velocity will change from u to v. So now what is that momentum? Therefore, the final momentum, thus the final momentum will be Pf, which is m into v. Next, we'll see what is change in the momentum. Change in momentum is nothing but final momentum minus initial momentum. Change in momentum will be nothing but final momentum minus initial momentum. So what is final? mv. What is initial? mu. And that's nothing but indicated as dp. Change in momentum. Like delta p, no? How we have? Same it is. It's like delta p, dp. No. Rate in change in momentum means always, rate means always with respect to time. So this will be with respect to time. Final minus initial upon time. I've already told you, rate in change is nothing but change in the momentum with respect to time. Now what is common between both of them? M is common. You just take out common. Now, kinematic equation, we know that. This you can do in your rough work and keep. Okay. V is equal to U plus AT. Everybody knows this kinematic equation. Now, what is the acceleration as per that? V minus U is equals to AT. Now, what is A? Nothing but V minus U upon T. So that is your A. So what is it? So you can write V, we know that A is nothing but V minus U upon T from the kinematic equation. How you got? Here explain. No need to show this this here. Only you should know. And do it somewhere at the side and keep how we got this. The acceleration is nothing but final velocity minus initial velocity upon time. So what we'll do, instead of this full thing, what will happen? Dp upon dt is nothing but m into a. You put it as equation 1. Now, just now we wrote the second law of motion. As per second law of motion, what does second law of motion say? Force is directly proportional, okay, to the rate of change of momentum. As per second law of motion, force is directly proportional. This is the sign for directly proportional to the rate of change of momentum. So force is directly proportional to what is the rate of change of momentum means dp by dt. What is dp by dt? Nothing but mass into acceleration. From where you got? From equation 1. dp by dt is nothing but mass into acceleration. We'll just remove out this proportionality sign. We'll put equal. Whenever you are removing out, we always put a constant. So let k be 1. We'll put the value of k as 1. So as per that, what will be this? Forces mass into acceleration. This everybody knows. Formula for force is mass into acceleration. So we derived the formula for mass into acceleration. So this is the derivation for force. If you are asked to derive the equation for force from starting whatever I have given, let us consider a body. From that onwards, you have to do this till here. And unit of force, we know that is Newton. So force is mass into acceleration. So what is 1 Newton? You want to know the definition? 1 Newton is defined as that force which is acting on a body of mass 1 kg produces an acceleration of, everything will be 1, of 1 meter per second square. See, what is 1 Newton? Force I want to say is 1 Newton. So when you'll get 1 Newton, when mass is also 1 and acceleration is also 1. 1 Newton is nothing but that force when acting on a body of mass 1 kg produces an acceleration of 1 meter per second. Acceleration. Next term, what you need to know is something called as a impulse. Impulse means the word itself, like it's a very short time, like a spike. Okay, impulse is nothing but a short, in terms of understanding, it's a force applied for a very short term. Example, cricketer. Another example, hammering a nail into the wall. So whenever you are what is that, holding a nail, pointer nail on the wall, and you're hitting its surface for a very short time, okay, there's no point like you hit this, what is that, hammer on the nail and keep it for 10 hours also, it will make that much impact only. Okay, so you have to remove the hammer, put it again, like quickly you have to keep on hitting. It doesn't matter for how long you're applying. That same hammer, if you keep for 10 minutes on that nail, it's not going to go inside. Okay, the impulse is what, a high force applied for a very short time. What happens is usually that short force, no, we cannot calculate accurately because it's for such a small time, we don't know how much Newton's force we are applying. So the word used is, we normally calculate for how long, means overall impact we calculate, not exactly how much force we are applying on the hand. From the hand, how much force we don't calculate, but how much is going into the nail, that we calculate. So usually as per this, the impulse of a force definition is, impulse is defined as so we cannot calculate just a force alone, I told you, okay, from the hand, because it's for a very small this fraction. So we cannot calculate exactly how much. So we take a product, total how much impact it is been making. Okay, so this is nothing but we are calculating how much impact it is making on the nail, suppose. So it's like product of how much force and for that much time you are applying. So impulse formula, the letter used is J, not I, J for impulse. So J is nothing but force for how much time you are applying. This will be a very short time. So J is F into T. So what is unit is force is Newton, and definitely this is time is seconds. So Newton second is the unit, NS. Impulse is force into time. What happens more the time? So you can write and keep more the time. Okay, that impulse very short time means it will have a very high impulse. Otherwise, it's okay. While explaining the examples, only I'll give applications. I'll be giving you. So that time I'll explain. Now we'll derive what is the relation between impulse of a force and change in momentum. Just now we saw what is change in momentum. Now we'll see how these two are related to each other. So same starting part will remain the same. Suppose this is an object of mass. Suppose I told you moving initially at u. Okay. Then what happens? I am applying a constant force on it. So the velocity will change to v. Same logic. Starting part, same explanation we have to write. Same thing you write now. Consider a body of mass m moving with initial velocity starting you have to write the same. Now let F be the force. Now only thing is here, this is for a very short time because impulse I told you always includes small time. Just think of hitting the on the nail, so that will remind you of impulse. So we hit the nail with the hammer for a very short time. So this force which we are applying is for a very short time. It will change the velocity to v. From u it will change to v the moment you apply some force. So what is the impulse formula? Impulse, we know that J is F into T. Just now we derived what is the formula for force. But force is how much? Just now we derived the equation for force. What is force? What is the formula for force?
MA.
M. So we know that force is mass into acceleration. So substitute here, that will become MAT. Again, we had seen what is acceleration. But acceleration is v minus u upon t. So put it here. M-A-T. So acceleration I'm putting as this. You can do like this. And stuff like this. You can put bracket no problem. Now what will happen? This t and t will cancel. Acceleration is final minus initial upon time. So I've just substituted a as this. So t and t will cancel. So j is nothing but m into v minus u. So j will be what? mv minus mu. So what is mv? Can anyone tell me? M into v in terms of momentum. What is mv? Yes, final momentum. And mu is nothing but initial momentum. That's why impulse is nothing but final momentum minus initial momentum. What is this? Nothing but change in momentum. This is nothing but your impulse. So right, therefore, impulse of force is equal to change in momentum. So this is the relation between impulse and change in momentum. Both are equal. So impulse we have studied, it means what? Like a spike. Okay. The more like sharp, for a sharp time you put, what will happen? More will be the impact. Okay. Shorter the time, more will be the impact. So what will happen is, some applications are there. First one is a cricket player lowers his hand while catching the ball. See, only for that fraction of a second, no, when the ball tries to hit the hand, what happens is the impact is very high for that small time. See, even if you consider the nail, okay, this nail only you consider, the moment the hammer hits the nail, only that second, that fraction of a second, that impact is so high that the nail goes inside the wall. Now that same nail, like hammer, for first second it will go inside, but after hitting only you keep it like that only, after some time at the second, okay, like on the clock you wait for the next second, still it will not make so much impact which had made for the first second just while touching the nail. So more time if you wait, if you can cross that 1 second, no, within that first second, if it doesn't hit the nail, then there will be no impact. So what happens is, you have to avoid the first initial second of the touch. So a cricket player lowers his hand while catching the ball. So if the hand is here, the moment the ball is hitting the hand, that impact will be so high. So what he tries to do, just try to lower the hand slightly. So what will happen? That much second of a time, the effect which the ball will make, it comes with a very high speed. So within that much second, the impact will go less. There will be less impulse. So that's why it tries to lower. So the reason, you can write it as, this is because by moving the hand backward or moving the hand lower, the cricketer increases the time of the catch. More the time, less will be the impact. Thus, the force exerted on his hand becomes much smaller and does not hurt him. So more the time, less will be the force. How I'll explain to you. Suppose the ball impulse is coming at, suppose, 20. Okay, that J is 20. The ball will have some impulse. Now the formula is force into time. Now this, it's fixed. The ball will come with certain impact or certain impulse. Now you know that force, we don't know how much it will be. Time, if you are keeping just 1 second, suppose you are giving that ball to hit your hand just for 1 second. So what will happen for it to make 20? Force will have to be 20. Okay. So with the force will fall with 3 newtons on your hand for 1 second if you are taking. But for the same thing, if 20 it is coming, now you are increasing your time of that. If you are taking as 2, so force will have to be how much? 10. So by increasing the time, you are reducing the force for the same ball. Okay, more the time, the less will be the force with which it is falling on your hand. So that is what it means. This is because by moving the hand, you are increasing the time, and that's why the force which is put on the hand will become small and it will not hurt him. More the time, less will be the force. So this was what I wanted to tell while deriving. Told while explaining the application only I'll explain this. So it means this way. As the time increases, your force will decrease. Second one, a person falling from certain height receives more injuries when falls on cemented floor than when he falls on a heap of sand. So if a person is falling on the sand, he will get less hurt compared to if he falls on the cemented floor. Why? Just try to think of the logic. Now this is a cemented floor. This will be a very hard surface. But heat sand will be what? Sand will be little soft surface. So by the time he falls, no, what will happen? At least the sand will go little down. with the impact. There's a movement of the sand. So for a small fraction of second, the person will go not exactly, he will not stop here. He will go little inside the sand. So the time of which he's stopping no, after falling, it will increase because he's going little more deep in the sand. But here what is happening, hard surface. So the moment he falls, there is no place on it to go more, like no more time. It just directly hits here. Here at least he's getting like few fraction of a second to go inside the sand. So what will happen here? Less the time he hits, means there's no time only for him, extra time for him to stop. Directly he will stop here at the cement floor only. So that's why less time, so more will be the force. That's why he'll be having more injury. So what you will write it as? You can explain this in your own words also. This is because when the person falls on heap of sand, it takes longer to stop. Slightly longer time. Longer means it's just a fraction of a second. Still that small second also matters a lot. Whereas on the cemented floor, the person stops abruptly. There is no time for him to go inside the floor. The person, you can say, stops abruptly. Abruptly means instantly, at that, you can say instantly also, whichever word you feel comfortable, abruptly or instantly, thus receives more injury, or thus receives more force, resulting into, this word should be there, more force and time, extra time. Okay, here the force we have to explain. Now this force we are telling about the fellow who is falling on the cement. You can also say this fellow has less force, however you want to explain. Longer time, so less force for the person falling on the sand, and for this cemented floor, short time, so more force. So the word force has to be there and the word time has to be there. And you know for whom it will be more time, for whom it will be less time. Then you can explain in your own words. Next question. Automobiles are provided with shockers. A bike, your car will have something called as shock absorbers. So why are they provided with this? So what happens when you are moving on some road which is uneven? Okay, and it will, what happens when you are moving on an uneven road, like on a speed break or whatever, or a pothole? So it will, your car will receive a jerk. Okay, so what happens to some extent? If these shockers were not there, then the impact would have been more. What happens is shockers, no, in between, by the time that impact from the tire, it reaches to your seat, what will happen? There it increases the time. If you're having a car, the pothole might be here, but now the moment your this, what is that, tire falls in the pothole, now there is some jerk which is coming up. By the time the jerk comes up, there is a shock absorber which is there inside the car, So it will reduce the time of that. By the time it reaches, it tries to absorb that force. And so by the time it reaches to you, the impact will reduce. So that's why you don't get too much of this impact. This is because when the vehicle moves on uneven road, it receives a jerk. Jerk means an impact, like a shock. So the shockers, what will do, increases the time. Time of the jerk to reach the whatever driver, and thus reduces the force. Okay, so overall impact will reduce. And the last one, China wears, or anywhere. The question was there in the textbook, so I just used the same one. China wears up packed with straw papers, or you must have seen any parcel or order, it comes in a bubble wrap, or they put some papers around it. Okay, or some straw in the sense the dry grass, like that, or even some kind of plastic. Straw papers before packing. China wares will be what, like those ceramic utensils, if you're ordering a ceramic bowl or glass, they will always be wrapped with some papers. Why? What is the reason? Because suppose if the box goes and hits something, or something comes and hits the box, okay, if the what is that vessel is suppose inside a box, if it is directly touching the box and something comes and hits this, so very short time, no, whatever is hitting, that force will be high because short time. But now if you are putting it somewhere in the center and then wrapping it with a bubble wrap, by the time this force reaches the what is that to that China ware, there will be a increase in the time, the force will reduce, and that's why there will be less damage. So this is because the straw papers between the China ware increases the time of jerk during transportation or wherever. And hence reduces the force and saves it from damage. Straw papers will increase the time. Okay, so like that there'll be many things, like normal day-to-day life, like why are buffers are there between the train. Okay, same thing, reason is same. There'll be buffers between the two bogies of a train, because the buffers will what happen, they will try to increase the time. Basically that's the same word you have to mention, the time increases, whatever they are using, no, that will is used to increase the time and to reduce the force, and there will be less impact and less damage. That's the only thing you have to explain. I'll stop here. Next class I'll solve problems.